Right, welcome everyone. This is now session 7. So we're going to just finish off the AutoCAD linking exercise we started last week. So that was under Revit short exercises, this one here. So the practice exercise, linking and importing CAD files. So to date we started a new project using the architectural template. We set up some levels. We imported the AutoCAD drawing here for the purpose of tracing. So initially we identified a couple of wall types, and then we actually traced or added the walls directly onto the AutoCAD line work. So that's what I call a process of tracing. So the thing is that you can either, add the walls by going point to point, or you can actually use the pick lines option and actually pick the line to add the wall to the AutoCAD line. Now this is the PDF that you used to identify the wall types and to also create and add the doors and windows. So when I say create, what do I mean by create?
Drag and drop an object into the template.
Yeah, so in the first instance you may have to actually load a family into the project, mainly the windows, but to actually create a different size of window, a custom size, how did you do that?
Type selector, we went there and then we edited we selected the window, then we edited the size for the height, and we made a duplicate, and then we went in and made the adjustments, and then we used that to then go and select.
Yeah, good. Okay, yeah, good. So you can appreciate that what you do basically is select an existing type of that window family, click edit type, go in and make a copy, a duplicate, give it a new name, and then change the size proportions to create that new type. So I think everyone has now done that. They've actually created all their window types and put their windows and doors into the building. Now, one of the things that I wanted to start off by talking about, or just drawing your attention to, is this instruction here, which is head height for all windows. Okay, so that being 2.1 metres. So what does that mean? Well, if we go back to Revit, this is the building that you're working on currently, the AutoCAD import exercise. Now, if you were to open up a 3D view and have a look at your windows, you'll see that some of them are actually quite low in the building. Some are actually quite high. Some of them may actually be at ceiling level. But ultimately, all of the windows need to be, or the top of the window, the top of the frame, needs to be at a height of 2.1 metres above floor level. Okay, so this is 2.1 millimetres or 2.1 metres above floor level. So once you've placed the windows, one of the first things you do is to actually check the head height. And if the head height, obviously the head height will not be correct when you place the window, you need to then go back over and select each window, and over in the Windows properties over here, and we call these the instance properties because the properties over here relate to that one instance of window. Okay. So over in the instance properties, we've got head height here, which is currently set to 2700. Okay. All right, sorry about that. So we've selected the window. We go across to its properties here, to this property here called head height. Now you can see that this one, mine, in my case, it's currently set to 2700. So to move this down to its correct position, so in other words, the top of the window is 2.1 from floor level, I physically type in 2100 and it moves the window down in the wall itself. Okay, so that's something you'll just have to go around and check all your windows. Now, I'd just like to show you something here. If I was to select the entire building, and I guess if you've got a building with a lot of windows in it, it's impractical to go to click on each one and individually change its head height. So you need to, I guess you need some other way of actually quickly achieving that change. So to collectively select all the windows and change their collective head height with one change in the properties. So if you were to drag a window and select the entire building, any ideas how we might do that?
When you turn off everything else.
Array.
Oh, hang on, there's an S thing in there.
Select all, SA.
There's a shortcut. Yeah, there's a shortcut. If you if you select one of the windows and type SA, it will select all items of that type in the project. Now, these windows are pretty well unique as types, aren't they? You know, more or less every window is a different type, so that's not going to work. So we sort of have to go back down to a category level. Okay, we want to select all the windows, regardless of their type. So the only way that we can do that really is to select the entire building and use something that begins with F. Okay, we have touched on this. Sorry? No, it's filter. Okay, do you recall have we had a look at filter? Okay, so if you can appreciate that in selecting this building, I've selected 41 individual objects. Now, if I drop this list down, see over here, multiple categories selected. If I drop the list down, it actually tells me what I've selected in my selection set. So 11 doors, 21 walls, 9 windows, and a 3D view. Okay. Now, if I go over to up to the filter button here, it also lists the categories that I've selected and the objects in each category. Now, if I want to just deselect doors and walls, I untick them, and that just leaves 9 windows selected. Okay, so anything that's ticked in this list is currently selected. So if I click OK, apply on that one.
OK or apply?
Apply for the moment. Okay, it keeps the filter dialog open. And then OK to exit the dialog. So I've got my windows now selected. If I then go over to the properties of these 9 windows, a property that's common to all of those windows, of course, is the head height, which doesn't have anything at the moment because all the head heights are different. Doesn't display a figure. So if I go over to the head height field here, or parameter, and type in 2100 and enter, move across to the view, and you can see that all the windows are now at the desired head height. All right, so we now have all our windows at the correct head height. So if I just return to the floor plan, the FFL floor plan, now that we have placed all our doors and windows in the actual building, in the Revit model, we have conceivably finished with the AutoCAD drawing. Okay, so we no longer need the AutoCAD drawing. So at this stage there's a couple of things that we do. Now, can I ask you to change the visual style of the floor plan to hidden line? Okay, change the visual style of the current view to hidden line. So the question is, what is the current visual style? What are we working in at the moment? What did we change it to in order to actually place the doors and windows? Wireframe. Yeah, wireframe means that everything is completely see-through. Okay, so what is the default visual style? I have mentioned it.
Grey trace.
No, hidden line. So hidden line is the default visual style for every standard view, okay, without exception. There's a couple of rare occasions when the view itself will come up in wireframe by default, okay, but not in projects. So the thing is that we toggle between wireframe and hidden line. We use wireframe for various reasons, and one of the reasons is so that we can actually see the underlying AutoCAD drawing in the floor plan. But once we've placed all our doors and windows, there's no requirement to see the actual AutoCAD plan underneath, so we go back to the default, which is hidden line. Now, the other thing that we do, if we've used an AutoCAD drawing, the other thing that we do is we actually switch it off in the floor plan. Okay, now this introduces another, I guess, mechanism, another way that we can actually hide elements in a view, hide by category or hide by some other means. Now, I've talked previously about doing temporary hiding, okay, and it's probably something that I'll need to cover again. But to hide the AutoCAD drawing in the current view, we have to do it through a mechanism called, and we go to the View tab here, and we go to the Graphics panel, and we open up something called Visibility Graphics, this one here. Okay, visibility graphics, and I guess this is one of the Revit fundamentals. This is quite important that I guess that I start introducing this now, and that you are aware of this particular area of Revit that is used to manage the visibility of objects in a view. Okay, now I'll come back to this from time to time, but for instance, up the top here I've got model categories on this tab, and I've got annotation categories on this tab. Now, if I wanted to hide the doors or the windows in the current view, I would sort of search the category list down here, and you can see the category of doors here with a tick beside it. So anything with a tick beside it means that any item of that category is visible or potentially visible in the current view. So what we're doing here is per view. It's not per project. Okay. Now, if I wanted to turn off the door category in the current view, I'd untick this box here and click Apply. And if you have a look at the underlying floor plan, you'll see that the doors disappear. So they are said to be hidden by category. okay? Same with the windows. If I scroll down to the end of the list here, I've got walls and windows. So if I untick windows and click apply, it turns my windows off. Now, leaving this dialog open, if I go across to imported categories, just go across to imported categories. Now, I think we did briefly touch on this. I'm not sure if we have or we haven't, but because we have imported this AutoCAD drawing into the current project, Revit sees that as an import. It's an imported item. So it's classified as an imported category, okay? Now you can see here, this is the AutoCAD drawing that we've brought in. And do you recall that we actually turned off some layers? I'm not sure if you remember that. When we brought the AutoCAD drawing in initially, we actually clicked on it and then we went to a query button. Yeah. Then we clicked on a line on a window and we're able to click hide in view, and it turned off all the windows. Well, this is where you actually turn them back on again. So visibility graphics, imported categories, this is the AutoCAD drawing that we have in our project, and when we hide the layers of the AutoCAD drawing, this is where they get switched off. Now, if you want to switch them back on again, you just re-tick the boxes. Now, we don't want to do that. We actually want to untick and turn off the entire AutoCAD plan in the view. We don't want to delete the AutoCAD drawing because we might need it again, but we just want to turn it off. So we untick the box at the top here against the AutoCAD drawing name, and then when you click the apply button down here, it turns off the AutoCAD drawing in the view itself. Now, if I go back across to model categories, okay, if you have turned off the windows and the doors, I'll get you to tick them back on again. So put a tick next to windows and put a tick next to doors and then click apply. Okay, so I'm just starting to introduce what we call visibility graphics. Okay, so this is the way that we control what is visible in the current view. So we'll close that. So is that okay? Any questions on that? So now I just want you to have a look at your floor plans now. Just have a quick look and see if you can detect anything that is wrong with the floor plan. And the clue is windows. Even if you compare it to the floor plan here in the initial PDF, okay? Now I'm not talking about tags, I'm just talking about the windows.
The wrong window type?
No, no. The thing is that I guess if you followed my schedules here, you'll have put all the windows, the correct windows in and the correct sizes, and they're all now at the correct head height. We've turned off the AutoCAD drawing. We have changed the visual style back to hidden line. However, some of the windows have disappeared. On which side of the building? So where have they disappeared?
On the western side.
On the western side, along this wall here, haven't they? So, I mean, if you mouse over the wall itself, you'll actually sort of see the outline of the windows. Can you see that?
Yeah.
Okay. So the question is why? All right, and that's a rhetorical question because I'm going to give you the answer. Okay. So all of a sudden we've put the windows up to their correct height and we've lost some of them. Now, I guess to explain why, I'm just going to open up the western elevation. You can do the same if you like. Now, when we look at a floor plan, what are we looking at? No, but I mean in terms of what part of the building are we looking at? What if the building had a roof? Why aren't we seeing the roof?
We're looking straight down on that.
We're looking directly downwards or straight from above, aerial view, but we're looking inside the building, aren't we? Okay, so to look inside a building, what do you have to do to it? Cut it through, slice it through. So take a cut through parallel to the floor level. Okay, so if you can appreciate, I'll just come back to the floor plan itself. So in order for us to sort of see what we're seeing with the walls, the doors and the windows, the software itself is actually cutting through the building. Now, the question is, at what height is the software cutting through the building?
You set it to the ceiling height.
No, well, again, these are all rhetorical questions because I guess the thing is that
It's not cutting through the first floor, is it?
there is a predetermined height at which the software cuts through the building to allow us to see the building like this, as in a floor plan. So the walls are being cut through, the windows are being cut through, everything's being cut through at a set height. Now that height happens to be 1.2 metres. Okay. And I guess if we go to a 3D view, and and I don't really want to, I don't want to confuse you with this too much, but if I right mouse on the little house symbol up here, and I go orient to view, and go to floor plans, and I choose FFL, what this does is that sets up the 3D view based on the level at which the floor plan is cut through. Okay. So it's still a 3D view, and probably this hasn't worked as well as I would have expected, so please, my apology, I'll disregard that one. I was hoping that would work a little bit better. Okay, sorry about that. So going back to the floor plan itself is being cut through at a height of 1.2 metres. Now, if we go to the west elevation, if I draw a reference plane, okay, a reference plane through the building to represent what we call the cut plane height, and I put a dimension from the floor level up to that reference plane. Okay, this is not something you would normally do. This is just for me to try and explain what's going on with the floor plan and the reason why we can't see some of the windows in the floor plan. So if I set this reference plane at a height of 1200, okay, so that's where the building is being cut through in the floor plan. Now, Note that these smaller windows are actually sitting above that reference plane. Okay, this is a larger window here, and it's actually just a whisker above that. So the reason that we're not seeing these windows here is because the cut plane is beneath them. Okay, so the cut plane itself needs to be cutting through windows and doors in order to actually see them in our floor plan. All right, so if I was to actually pull this window down, it would we would actually see it in the floor plan. The alternative is that we actually lift the cut plane. So if I take a measurement from the floor level to the middle of one of these windows, you'll see that to the centre of that window is 1.8 metres. So if I was to lift the cut plane to 1.8 metres, it would nicely cut through the larger windows, of course, and also pick up on these smaller windows, and we could then see them in the floor plan potentially. So what we do is we go back to the floor plan view, and the cut plane of the view is a property of the view. It's something that we change in the view itself. So the properties that relate to the view itself are all over here. These are the view properties. And if we scroll down to an area called extents here, and specifically something called view range, and to change the view range settings, we go across to the edit button here. Now, I guess if you want to try and sort of understand a little bit more about the view range itself, as in the settings here and this one down here, if you click the show button here, the software gives you a little graphic here which sort of explains what the levels are in relation to the current view. So number one is the top, what we call primary range. Number three is the bottom primary range, typically at the bottom of the level, current level, so that's floor level. And then number two is what we call the cut plane. Okay, so that's the level at which the software cuts through the view to give us a cutaway view of the model. So as you can see, the cut plane is currently set to 1200. Now, in that west elevation, we determined that the cut plane ideally needs to be lifted to 1.8. Okay, so if I physically type in 1800 in that cut plane setting, and I click apply, just keep an eye on this wall here. My windows reappear. Okay, so I can now see the window here and the two windows here because I've lifted my cut plane. So I guess the thing is that when you are, particularly your windows, your doors are really, because your doors go to 2.1, they're not generally a problem. It's just your smaller windows that may sit above your cut plane that are not being picked up by the cut through. So this is a standard procedure, I guess, is to, once you've placed your windows, you put them up to the correct height, you'll just need to, I guess, work out what the minimum cut plane needs to be to pick up on all your windows. Okay, So in our case, we'll just go with the 1800. So we can OK that. And now
that does mean that you actually you cannot have things that are offset like that and see them in this view.
yes, you can. There is another way of achieving that.
You don't have that yet?
Not at the moment, no. No, we can individualise cut planes. We can actually go down to on an individual per instance basis with a cut plane, but I don't want to go there at the moment. So I just don't want to confuse things at the moment. Yeah. Only to say that this is a setting that affects the whole view. Okay. But yes, there may be occasions where you just want to pick up on one thing. You know, you might want to leave the cut plane where it is and pick up on just one item to actually show it, and that is possible. All right. So what we'll do next is that we'll just very quickly add a floor to our building, and then we'll have a look at adding a roof. Now, we are in the floor plan view. Now, if we're adding things like floors and roofs, so we have on our build panel here, we have roof and we have floor. Okay, roof and floor. So architecture tab, build panel, roof and floor. Now, just to place a 150mm generic floor underneath our building, we select the floor tool here. Okay, select the floor tool. Now, over in the properties here, of course, we've got in the type selector, inside the project, we've got a number of different floor types. We're going to stay with a generic 150. Now, in terms of things like roofs and floors and ceilings, the way that we create these is a little bit different, and it introduces a different way of creating objects in Revit. So to date, we know with walls we actually draw walls. With doors and windows, we place them in a wall, which is a host. If we need a door or window that's not in the project, how do we actually get them? How do we bring them in? Insert, yeah, load family. So things like doors and windows are actually what we call loadable families. Things like floors, roofs, ceilings, and some other building type components are considered system families. Walls are system families. So as opposed to loadable families, things like floors, roofs, walls, ceilings are known as system families. So they exist inside the project. If you want to create new ones, you actually duplicate and create new types, okay? But these system families can't exist outside a project. In other words, you can't load them in as through load family. And we generate them by a process of sketching, okay? Because they are generally items that walls are vertical, things like floors are horizontal. We generate them in a floor plan generally, and we generate them through a process of sketching. Now, when you click the floor tool and you select your floor type, you notice up here, modify create floor boundary, this tab up here. You've got a number of draw tools, so you've got your standard draw tools. What we're creating is what's known as a boundary line, so we're actually defining the boundary of the floor. over here on the options bar, we've got this option here, which is extend into wall core. Okay, I won't go into the explanation of that one just yet, only to say that we need to untick it. Okay, essentially by unticking it, what it allows us to do is generate the floor to the outside edge or the outside face of the external walls. Okay. Now the default draw method is something called pick walls, so we leave that as it is. And if you approach one of the walls and click the outside of the wall, it adds a magenta sketch line. Okay, now importantly, it has to be on the outside of the wall. Now, if you then click the wall next to it, on the outside, it continues that magenta sketch line. Now, as you keep clicking your walls, it will continue sketching. Okay, single click. And then finally, when you click the last wall, it completes the sketch. So we now have the building enclosed by this sketch. Okay, now we are now said to be in sketch mode. In sketch mode, the building itself goes to a half tone. We get this modify create floor boundary tab, which gives us some additional options. Now we have this mode panel with a red cross and a green tick. Okay, so whenever you're sketching in the software, once you have sketched something, to generate the item that you're working on, you have to then click the green tick to finish sketching and exit edit mode, and in doing that, it generates the actual building element. In this case, the floor. So if we were to have a look at that in 3D, you can see now that you've actually added a floor beneath the building itself. So I guess the thing is that, yes, this is a very simple floor, and it's not obviously not accurate in terms of the correct construction of a floor, but it's just a floor per se. Okay. So this is just really introducing, I guess, the concept of sketching to generate building elements. If you wanted to edit the floor itself, if you wanted to change the floor, if we go back to the floor plan, the FFL, so the thing is, I guess the question is, can you select the floor? Does it pre-select, and can you select it by actually clicking on it like that? If you can't, I'll just clear that selection. Just below the modify button, you've got to select. See the word select? And there's a drop list there. Now, see these are selection options. Okay. Now, as a rule of thumb, okay, whether you're here at TAFE or you're at home, the first 1, 2, 3, 4 need to be ticked. The fifth one needs to be unticked. Okay. So if you are having problems selecting certain objects in views, check these settings. One of them is the select elements by face. So if that's unticked, I can't select. I'm clicking on that floor, but I can't select it.
Because you can't select the face.
Because it's not allowing me to click on the face of it to select it. I can go to the edge of it, hit the tab key a few times and then get it, but I can't select it by face. And that's this particular setting here. So if I re-tick that one, I can then click on it here and select it. So this is what's called frustration avoidance. All right. Okay. So this and it also stops an email to me. All right. So yeah, these, by the way, these settings here are repeated down here. See down where I am down here? Same settings. Okay. So you either if they have a red cross against them down here, it means that they are disabled. Yeah. Okay. So if I wanted to edit this floor, change its shape in some way, I can select it. I can go up to the mode button here and click Edit Boundary. See the Edit Boundary? Now, when I click Edit Boundary, it takes it back to its primary sketch lines. Now, if I wanted to perhaps add another section of concrete floor here, maybe for a veranda floor, I could use my Modify tools here, Trim Extended Corner, pick this sketch line, and pick this sketch line, and create a corner out here, okay? But what I have to do here is actually delete the inner sketch lines here. I have to delete them. Otherwise, Revit's going to throw up an error. Okay. I know, and I guess you have to understand the rules of sketching, and I guess what you can and can't do. But essentially, with your sketch lines, if you have sketch lines that overshoot like that, it's going to give you an error as well. This has to be sorted out. Okay, these sketch lines have to be removed. And these ones have to be fixed up with Trim Extended Corners. So
how do you remove them? Just delete?
Just select them and delete them. So at the end of the day, with your sketching, each sketch line needs to be continuous, no breaks in it. They have to join at corners, okay, and they have to. It has to form a closed loop, continuous loop. So having done that, having made that change, I can then finish and regenerate the floor. Have a look at that in 3D, and it's now extended that floor out to this part of the building.
So if I click on the one I want to delete, I just press delete?
Delete, yeah. So just click on it and use the delete key on your keyboard, or this delete button here. Okay, just some final words, I guess, with sketching. So if in fact you have perhaps added too many lines in one place, so if I actually click boundary line and pick walls, and let's say I put another sketch line here and another one here, and if I keep clicking, I'll keep adding sketch lines. Now, and the thing is that if you've got several sketch lines, one on top of the other, in one place, the software is going to give you an error. So if I finish now, it's made a liar of me. So, so I'm trying, I'm trying to sort of here. Let's try that again. Lines. Maybe I'll do this one.
You might not have green clicked after you did all those lines.
Yeah. So the thing is that I've actually managed to put a sketch line along here, and it says highlighted lines overlap. Lines may not form a closed loop. So, and I'm doing this deliberately. So here as well. And I guess when you go to finish, you'll get this error here. So until you actually resolve the problem, you're not going to get any further. So I guess the thing is that you need to, understand what you've done and how, mainly how to resolve it. So if you click continue, I guess the thing is if you suspect that you have maybe two lines in the same place, visually it's hard to see. But what I tend to do is actually drag a crossing window across those sketch lines there. And what that tells me is that I've got two there and I should have one. Okay? So, and this is part of the, I guess, the problem solving technique is that, okay, well, if you suspect you've got double sketch lines, that's the way to test for it. So, okay, well, I've got two here, so I'll click on one of them and hit delete, and that leaves one underneath. So if I drag across there, I'm now back to one. So that's fixed that. Same here, okay? So I've got one here, and I've got a shorter one here, okay? So if I click the shorter one and delete and leave the longer one, hopefully that's going to work, which it does. So when you're sketching, you just have to, I guess, understand the reasons why it's throwing up an error, and I guess, understand how you actually problem solve. If you're just not getting anywhere at all, then just edit and delete all the sketch lines and start again. Okay, that may be quicker than trying to work out what's going on with the current sketch lines. Okay, it's all about,
Well, it's time efficient because it's clear and stuff.
Yeah, it's going to take you longer to try and work out what you've done as opposed to deleting the lot and then starting again. So
that's a call. It's a judgment call.
Okay, so would you like to tackle the roof next?
Yes.
Okay. All right, so we need to move up to a level that's appropriate to create a roof. Okay, so we need to actually physically move up to the top of our walls. So to do that, we actually open up a new floor plan called FCL. So FCL is finished ceiling level. So double click that floor plan. Now we're working in floor plans, we're not working in ceiling plans. Okay, so still working in floor plans.
Yes, actually that makes sense.
Yes. So we've just, more or less, we're still looking downwards, but we're actually at 2720 now, not 0. So this is where we generate our roof. So I'm just going to close some of these other views. So FCL. Now, if you click the bottom part of the roof tool here, you've got a number of options. You've got roof by footprint, roof by extrusion, roof by face. You've got roof soffit, roof fascia, and roof gutter. Now, I guess if you're not familiar with the terminology, you all know what gutters are?
Yes.
Right. And many of them were overflowing yesterday. Okay. unable to handle the capacity or the flow of water. Okay. Do you know what a fascia is?
Yes.
Yeah, the side of it.
Yeah, so it's that sort of vertical component that sort of attaches to the base of the roof that hosts or hosts the gutter itself. Soffit. Soffit, also known as eave lining. So if you have an eave overhang, okay, and you look underneath the eave, you'll see a horizontal sheet that goes from the inside of the fascia back to the brickwork. Okay, so that's the eave lining. So it's normally a 4.5mm fibre cement sheet product made by companies like Hardy. I guess, many years ago, in older buildings, the eave lining was actually made of asbestos.
Yes.
Yes, so if you are working or doing something with eave linings on older houses, just be very careful. Don't drill or cut them.
Get it removed.
Unless you get them tested.
Yeah, tested. If they're positive, you got to get a contractor in there certified to do it, to remove it.
Yes. So if you're not sure, don't touch it. But that's an eave lining. The Americans call them soffits. We call them eaves lining. Okay. And in fact, here you see the little image here on screen showing you what they are. Fascia and gutters. Now we're going to generate a roof by a process called footprint, and again, in a similar way to the way we created the floor, we're going to sketch the outline of the roof, and we're going to include an eave, so the roof extends beyond the outside face of the wall. So select roof by footprint. So as with many things in Revit, we have some options to contend with. We have to decide what type of roof we want to place. The software comes with many roof types. We can create our own if necessary. A lot of these roofs are just what we call generic, so they're just one layer. You could conceivably create a roof with several layers. If you know a bit about roof construction, what might those layers be? Insulation, yes, good.
Oh, yes, the membrane.
Membrane, yeah, and the type of cover, whether it's tile or iron.
Concrete or iron.
Iron, yeah. You could include a layer for the rafters, the purlins.
The heating as well?
Sorry?
Heating?
Not so much the heating, no. You're talking about air conditioning? No, not so much that, but just the roof, the construction of the roof itself.
What about sloped glazing? Is that just like literally tiled roof?
Sorry, are you looking?
Skylights, probably.
Skylights are something you probably add to the roof after you've built the roof.
I'm looking at basic roof and I've got generic here at 400mm.
Oh, sloped glazing.
Yeah.
Funny, I've never noticed that before. Yeah, that would. That's for your veggie garden. That's for your
Glass house.
yeah, greenhouse.
Greenhouse glass house.
Possibly, possibly. Yeah,
Lovely.
possibly.
Lovely. We don't know, but
yeah, that's interesting actually, because you could actually use that for a skylight. Yeah. Providing you can embed one of those roofs into the other roof, which is a possibility. But No, I've never, that's, yeah, it's not something I've never even considered, so. So we'll go with the generic 125. Now, the overhang, we'll go with 600. And this time we actually click Extend to Core. The Extend to Core, I will, sort of talk about this maybe in a later session, but not just at the moment. Only to say that the Extend to Core directly affects the pitching point of the roof. So it's the relationship between the roof and the wall as to where it pitches from. Okay, so to get the pitching point to be more accurate, we actually choose Extend to Core. Okay, so 600, now we've got Define Slope here, and that one's ticked. So what we do now is we actually approach each of the walls, and you'll see that on the outside of the wall we have the blue dashed line, which indicates the position or the location of the sketch line. Okay, so you can force it inside, but we want it outside. Makes sense? So when you left click, you'll actually place the first of your sketch lines. As you highlight each wall, the dashed line should be on the outside of the wall, and then you left click. And it's a matter of just working your way around and clicking each of the walls to generate that sketch line. The sketch lines will automatically join up, which is good.
We click a green tick button.
No, not just yet. We just want to get these sketch lines in place. Okay, is everyone okay with that?
I want to give me a roof pitch too.
It's giving me a 30-degree pitch.
Yeah.
Yeah, now the thing is that as you place them, you can see that the sketch line has the pitch and it has a little right angle triangle here. Okay, now the right angle triangle means that the sketch line is going to have, or that part of the roof is going to be generated at a pitch or a slope, and that slope is 30 degrees unless we change it. Okay, now if you hit the escape key a couple of times, okay, it'll just clear the sketch, the actual placement process. Now if I was to ask you to actually select all of the sketch lines in a closed loop, do you remember how you do it quickly with a selection method?
Try to save it.
So do a cross box.
Quicker than that? No. So there's a key on the keyboard that starts with T, tab. Tab, yeah. So if I mouse over this first one here, I'm not selecting it, so mouse over it so it pre-selects, hit the tab key and release it. They all pre-select, and then so this is chain of lines or walls, if I then left click that first sketch line, they all select. Okay, so this is a chain selection. So in this case it's perfect because these are a closed loop. Now the sketch lines are all selected. If you go over to the properties of those sketch lines over here, you can see that I've got 8 sketch lines selected up here. Okay, now you can see the overhang, collective overhang is 600. The pitch or slope is 30 degrees. And I've got extend into wall to core ticked. Okay, now what I'd like you to do is actually highlight the 30 degrees and change that, over type and change that to 22.5 and hit the tab key. when you've done that,
After we typed in, we just hit the tab key.
hit the tab key, yeah, just to tab out of that field. Okay, so when you've done that, you can actually just click out here in a free area, just left click, that deselects. So if you were to click on one of the sketch lines now, it would read 22.5 degrees. Okay, now note that you can change the pitch directly by clicking on the parameter here and changing it to whatever you like. Okay, so 30 or 22.5. So you can do it here per sketch line. So once you've done that, then go up to the green tick and click this one and finish. And if there are no problems with the actual sketch lines, you will generate the roof. Okay, so have a look at the roof in 3D. Have a look at it in, let's say, the east elevation.
It's just created here.
Yes.
It's told you what it's going to be.
Okay, south.
It's calculated.
Why is it showing you the rectangular? Why?
Why is it
So
showing?
the pitch is at 30 degrees, probably a little bit touching now as we've summed up to, I think it's.
So what? Yeah, why have we got this rectangular part at the top of the roof?
So it's not actually meeting.
Sorry?
And then you've got that at 30 degrees it was meeting.
Ah, is that the hip?
No, this relates back to the conversation we had about the windows not showing in the floor plan.
Oh,
Cut plane. So,
Because we lowered the roof line or the degree of the.
well, the thing is that
It's a default there.
yeah, if I was to actually open up the let's go for the west elevation. If I put a reference plane through here, and I put a dimension from the ceiling level up to this reference plane, and I then lift that reference plane up to 1200. This is a graphical representation, I guess, of where the cut plane. So every view has a cut plane. So
Default.
yeah, so we're working at the FCL in the FCL floor plan, and that has a cut plane at 1200. So that cut plane is cutting through the roof at that height, so it's chopping the top off. Okay. So if I was to lift that up to there, for instance. If I was to lift that up there, if we actually go back to the FCL floor plan and we change the cut plane to 1600, it's going to show us the entire roof. So do you want to do that? Do you want to try that?
FCL.
Yeah, so you need to go back to the floor plan that we used to generate the roof, okay? Now the cut plane is part of is one of the properties of the view, okay, as in all plan views, and it's under extents, view range, edit, and cut plane. So we said, okay, the cut plane, if we lift that to 1600,
Apply. Okay.
So that's the associated cut plane. It's set at 1200. We go to 1600.
Yep.
yeah, so cut plane, yeah, so set it to 1600.
Apply.
Oh, just click OK. Yeah. All right, so we can now see the whole roof. All right, so we've learnt how to generate a roof. We're not going to spend too much more time on this particular roof. But what I'd like you to do is, if you can just close, be in the FCL view, close any other views that you currently have open, and just open up the default 3D view. And what I'll get you to do is, can you just go to the View tab, go to the Windows panel and click Tile Views. So the shortcut is WT. So that if you can have your views side by side, so you've got a 3D view and your ceiling floor plan.
So we've got FCL and FFL and a 3D view?
Just FCL and 3D, just two views. So what I'd like you to do is, in the floor plan view, just select the roof. Now, I guess if you can appreciate, can anyone tell me what sort of style of roof this is? Yeah, it's a hip roof.
How do we get tile views again? Sorry, T.
WT is a shortcut. Now, do you know what I mean by gable? The word gable, or what a gable is?
That bit that comes off the front of it.
So, yeah. So, I guess what I'd like to do now is actually, I guess, convert the roof from hips to gables. Okay. So we'll still have the you know, the centre ridge, the major ridge here and the major ridge here, but the ends of the roof are going to convert to gable. So to do that, we select the roof, and when you select it in one view, it obviously selects in the other. Now, to make a change to the roof itself, in much the same way that we changed our floor, we have to go up and edit the footprint up here, edit footprint, which takes it back to its primary sketch lines. So you can actually do this in either view, but if we just work in the plan view, and to change the ends of the roof to a gable rather than a hip, what we do is we actually select each of the sketch lines on that part of the roof. So in this case, this minor roof, we select the sketch line. At the end of the building, we select the sketch line, and over here we select the sketch line. So this one, and this one.
So I've clicked on all three, but it keeps kind of...
We have to select them all together. You have to actually hold your control key down and then click, click and click. So remember, the control key adds to the selection set. So 3 sketch lines selected.
3. 1, 2, 3, 4, 5, 6.
1, 2, 3.
Oh, that's all. Right, okay.
Yeah. No, it's just the sketch lines at the ends of the 2 ends of the building and the front at this front protruding section here.
How can I select this group?
Hold the control key down while left clicking the sketch lines that you want to select. So I'm holding the control key down.
So just hold that down like that. And then click while still holding that. You can do it.
Okay, now
And then we only want to
So we can very quickly convert a roof from a hip to a gable by just making a change to the sketch lines, in this case the 3 of them, and the change that we make is that the only thing we do is we untick this option here, which is define slope. Okay, now it's also over here in the properties of these sketch lines, define slope. So untick that option there. Now, you could also change the overhang to let's say 300 for those. And you'll see that, see how the sketch lines move in closer to the building?
Yep.
Okay.
So we press apply after we've done the 3.
Yeah, so notice with that, the change to those sketch lines, notice that they've now lost that little right angle triangle. So that's gone. Now when you click the green tick to regenerate the roof, it's going to look quite different.
Just a second, sorry.
Okay, so so you can now see that the roof, we've changed the style of the roof now to gable. Now, the result there is that we've now got so these open sections of all these sections of wall that are missing. So we've got these open sections into the building. Now, there's a tool that will allow us to actually infill the wall at the top, so that actually infills and goes up inside the roof itself. So for the 3 walls that are affected here, so this one, and this one, if you just do one at a time, just select one of the walls here. Up on the ribbon up here, see the Modify Walls tab. We've got two tools here, Attach Top to Base and Detach Top to Base. So what this does, attaches the selected wall to model elements such as roofs and floors. So the way this works is that when we select that, what we do is we, up in the options bar, we have attach wall. So we've got top selected. What we do here is we actually select the object that we're attaching to, i.e. the roof. And in selecting the roof, in this case, it pulls the wall up to attach to its underside. So in each case, just to fix up each of those walls, we select them, attach top to base, and then select the roof. So select the wall, attach top to base, and select the roof. So I'm going to now just remain in the 3D view. So I'm actually going to just jump across to the floor plan and close that view. So my 3D view is now the primary view. Okay, so how are we going? Everyone okay with that?
So once we've done that, just leave it.
Yeah, attach top to base.
Yes.
Click.
All right, so just to finish off our roof, let's just quickly have a look at adding fascias and gutters. So, this is best done in a 3D view. Now, if you then go back to the Architecture tab, click on the bottom of the roof tool, okay, so that you have access to these other options here. So initially we're talking about adding what's known as a roof fascia. Now, if you then if you select fascia, we only have the one type, so you don't need to worry about selecting a type. There's no options to choose here. But essentially the way this works is that if we sort of zoom into the gable above this front section here and pick on the top of the roof line here, see the part that's highlighting? So just click there, just click once, and then move across to the other side and click the other side and click once as well. And then just click modify, hit escape. So although this is not technically considered a fascia in building terms, it's really more of a barge board perhaps, that sort of just as a decorative feature that is attached to the end of the gable roof. We use the fascia tool just to add that. Now when you select it, so after you've added it, if you select it, you'll notice if you zoom into the very end of it, you'll see that there's a little bubble there. Okay, so at the end of each of the these boards, there's a little bubble there that says drag segment end. Now if you click and drag that, in this case downward, it will extend the that particular part of the barge board. Yeah, so if you notice that you've actually got, in this case I've got sort of, just over 190 millimetres as an extension. Now if you want to actually extend by a set amount, you can actually type in what you want this to be. But the trick here is to not put in a positive amount, but to put in a negative amount. So if you wanted this to extend by an even 200, we put in minus 200.
It's showing me, but it's not letting me do it.
And enter. So that's extended that side there. Now if you want to extend the other side, click on it again, just move around. So initially you've got to click and drag it out. When it's out, or when it's extended, click directly on the offset or the parameter here and just put in this case minus 200 and enter. If you type in a positive value, okay, if you type in a positive value,
Measuring from the ground.
yeah, it's an odd sort of situation. But if I take that back and then bring it back out again, if I put in positive, it sends it back up that way. So if I drag it out there and then put in minus, it extends it out. So it works in the opposite way. So what I'll get you to do just quickly is if you can just add barge boards to the end of the other sections of roof and just extend them out by 200. So again, like with most things, if you actually select the first one you've placed and do a create similar, so CS, and then select the top edge of the roof here on the southern side. Hit escape a couple of times or click modify. Select the barge board again, and then just drag it out on one side, -200, and then out the other side and -200.
Lost.
All right. So once you've added those three sections of barge board, what we then do is just add the horizontal sections of fascia. So this is in the true sense of what a fascia is. So again, just select one of the barge boards that you placed. Either select this button here or type CS, create similar, and then just select the top edge of the roof here. So just to add the fascias along that part of the roof, those two parts. Now, what you can do while you're in the fascia tool, just move around to this part of the model, and then in each case just click the top edge of the roof to add the fascia boards. Okay, once you've done added the front ones there, you can just move around to the back of the model and just add the last one here, which goes right down the length of the western side. Yeah, all right, we'll just quickly finish this off. So the last thing to actually put on is the gutters themselves. So again, if you sort of zoom in fairly close, now if we go to the roof tool, the roof split button, and we choose gutter, and to place the gutter, now note where I'm actually pre-selecting, so it's the outside face of the fascia, so it's the outside top line here. So just when it pre-selects, just click to add the gutter, and then just move around to this other piece of fascia, and click the top outside line there.
Top outside line?
Top.
Oh yeah, sorry.
Yeah. So clicking the top of the fascia, but the outside edge. So, and just move around the model.
I seem to have lost my ability to be able to click on my tools, like my ceiling and my roof. They're like not colourful. Is there any reason why?
Okay, and just lastly, so modify place gutter. So we're just going to move around to the back of the building, zoom in nice and close, and then pick the top outside edge to place the long section of gutter. All right, well that's about as far as I want to go with this particular exercise. So I guess just to recap, the exercise was based around the ability of Revit to allow the import of an AutoCAD file for the purpose of tracing. So we've actually generated a building based on that technique. We've also had a look at creating custom windows, different size windows, different types, and we've now looked at adding a basic floor and also adding a roof, changing the roof, and extending the walls up, and also adding things like fascias and gutters. So at this point we're going to finish this exercise, so that's as far as we're going to go. So what I'll get you to do is just do a final save on this particular exercise. Close any hidden views or close any open views, and just close the project. And what I'll get you to do is at some stage, if you can actually just upload this particular Revit file to your OneDrive. So again, so with the exercises that we're doing and throughout the unit, I'd like you to save the Revit file onto a local drive, which is a USB drive, and also copy it up to your OneDrive. So we're going to move on now, and we're going to start a new exercise. So if I can just ask you to come back to the Learn site, to the Revit Short Exercises area. All right, so if you just go down to the very end of the section Revit Short or Revit Exercises, so the one we've just completed is this one here, this practice exercise. We're now going to move on to what we call class exercise 1. So given that we're going to, this is the first of a couple of more substantial exercises that we're going to work through. So class exercise 1 we call is a simple house drawing. It's this one in particular is actually single story, very similar to the last exercise we did. When we get to class exercise 2, that's actually a 2-story building. So with this one, if you can just initially just open up the PDF, which will give you a little bit of guidance. If you can't see, you might have to refresh your screen, F5 your screen. Okay, so this is class exercise 1. Now we're going to draw up this building, this little house. And I guess in many ways it's probably very similar to the previous exercise. However, for this exercise we're not going to use an AutoCAD drawing. We're actually going to draw freeform. Okay, so you're going to work from a floor plan to generate the initial wall layout or set out. So if you scroll, if you go to the very end of the document, you'll see that there's an A3 sheet at the very end, which is essentially what we're going to produce. We're actually going to go to the, we're actually going to sort of take this from this exercise from the very beginning. We're going to draw it up, obviously, as we've done previously. We're going to add dimensions, room names, labels, a north symbol, and we're actually going to ultimately put it onto an A3 sheet. And potentially, if you wanted to print it out, you could, but we're actually going to convert it or print it to PDF. So we're going, as I say, this is the end result. So this single A3 sheet. So just going back to the beginning, the start of this particular exercise again is identical to the way we started the previous exercise, where you're going to start a brand new project from the architectural template. So it's important that you choose the architectural template to start this one, which will give you obviously the correct wall types and so forth. When you have started the new project, I'll get you to do a file save as, and we're going to call this one exercise 1 simple house, and I'll ask you to actually include your initials in the file name. I'd also like you to control or restrict the backups to 2. Okay, so 2 backups only for this particular exercise. So if we can sort of get into that habit for all new projects, so that as you're saving the project, at any point in time, you've actually got the primary file plus 2 backups, not 20. Okay, so once you've saved the file, you're then going to proceed to step 3, which is setting up the levels in the project. So I'll get you to just to work through those first few steps, and then we'll have a look at generating the wall set out. Okay, so again, just when you're saving the file, just direct the actual save back to your local USB devices.
Is it save as project?
It's always save as project, yes. Okay, so once you've selected your save location, put in the file name, you'll then click the options button here. So this is where you actually restrict the maximum backups, in this case to 2. And then click save.
So once we've named it,
Oh, yeah.
All right, so having done that, you're currently in the ground floor floor plan. You're going to open up the east elevation, and you're going to set up your levels.
Yes. If that's all.
Okay, so you've got a floor level at 0, ceiling level at 2720, and you're going to create a non-story level to indicate the ground line at 150 below floor level.
Create that extra line that's not there. Don't worry about it just yet.
When you are renaming your levels, just be careful. You know that to respond yes to this message here. Do you know why or what that does?
Makes it, I mean, you
Changes your properties.
Drop copies across to every single one of your plans and layouts.
Yeah, well, more importantly, it actually, I guess it aligns or synchronizes the name of the level here with the corresponding floor and ceiling plans. Yeah. So respond yes. Okay, so that the name here, the name of the level here matches the floor plan name over here, and same with the floor level. Now, once you've renamed your levels, of course, you're going to adjust the height of your ceiling level. So that becomes 2720. And you're going to add a level below floor level to indicate the ground line. So again, to add the level, we go to the datum panel, we click level. We go across to the options. Now, what do we have to actually change here to make it non-story? No.
Building story?
Well, basically you untick make plan view.
Untick plan view.
So that by unticking that, by unticking make plan view, so I guess the thing is that what's the definition of a non-story level? By definition.
One that doesn't have a...
Well, it's like a reference plane.
Yeah, so it acts as it indicates the height or the depth of something, but basically it becomes non-story because there are no floor plans created when we create the level.
So we didn't go and delete those other views after when we created this floor?
Yeah, because we went through in a previous session. We went through how we create we create levels but by default we create floor plans when we create the level. So by default, when you create a level, it'll automatically create a floor, a ceiling plan, and a structural plan. But if we untick this option here, it's not going to create any plans at all. Okay, so to produce a non-story level, we untick this option here. To actually physically add the level, we choose this option here, which is pick lines. Okay, so whenever you're adding levels, I do want to see you using this option here. And the offset is going to be the distance from an existing level. So in this case, it's 150.
Minus 150?
You don't have to put in the minus, you just put in 150. Providing you add the level, the new level below floor level, it's going to automatically put it in it's going to indicate minus 150. Okay. Now, when you have added the level, okay, it's important that you don't keep clicking. Okay, just click the modify button and exit the tool. And once it's created, you're then going to select it you're going to find the little symbol here to add an elbow and click that. You're then going to use the drag bubbles to pull the level head down so it's not overlapping the 0 up here. So separate the level heads. And when you've done that, you'll click directly on the level name. So left click, and change this to ground line. Now, once you have changed it to ground line, you may then have to click the level again, the level line, and just adjust this, the vertical section of the level line, so it's not passing through the text. Okay, so that's how your levels should be presented. Okay, so once you've set up your levels in the east elevation here, you're then going to go back to the floor plan, which is where we're going to ultimately begin drawing our walls. All right, can I just get you to select the section line in this floor plan and just delete it. Now we're going to, moving on to the next page, we're going to modify an external wall type to create a new one, which we're calling brick veneer 240 timber. So in standard construction in here, in the what we're using in standard construction is a wall type called brick veneer 240 timber, where the brick component of the wall is 110 mil thick. The timber component here is 90 mil thick, and the airspace or the cavity is actually 40 mil thick. So the wall type that Revit provides us with is brick veneer 250, but we actually want to take off 10 mil and then create a new one called brick veneer 240. And essentially all we're doing is we're actually reducing the cavity from 50 to 40 mil. But to do that, we actually have to either modify an existing wall type or duplicate it and create a new wall type and then make the change. Okay, so I think we'll do the latter. It's always safer to actually create a duplicate, give it a new name, and then make changes to that new type. Okay, if you make changes to an existing type, there's always the danger that it could be in use somewhere, and in changing it, you're actually changing some aspect of the project. So, just before we do that, what else do we have to do in this current view? What other change do we have to make in a visual sense before we actually start adding our walls?
Go to hidden line.
You can check that that's good. Just make sure that the view is actually set to hidden line. It should be, but there's another view related setting that we have to change.
Detail level.
Good, detail level. So what do we change it to?
Medium.
We change it to medium. Okay, so the next question is, where is it?
Down the bottom.
Down here,
Just after the scale.
next to the scale. Good. Okay, so we change that to medium.
Oh, that's right, yes.
Okay, so the thing is that we're sort of going through the typical setup of a new project. So these are the sort of these are the typical standard steps. This is the sequence that we go through. So there's a few things we have to do before we actually start adding walls. Now we're now ready to add our walls, but before we do, if I can just, we're going to set up this wall type next, but I just want to, I guess, draw your attention to the next page. Sorry, keep going. So this one. So where we are here, this is, well, just the next page on from page 4. Now this is our wall set out. So when we come to draw this building up, we're going to start adding our external walls first. We're going to draw in what direction?
Clockwise.
Clockwise. Yep. So the thing is that, I guess, just note the approximate size of the building, so that when you're actually drawing your walls, you don't have to be exact, but you have to be close. It's have to be close. So we're going to draw the external walls and generate this shape that's going to be fairly close to the actual size, but not exact. And we're going to draw in a clockwise direction. And when we draw our walls, we're going to select a location line. Okay. Do you remember what the location line is, or that setting?
Where the outside wall sits, whether it's in the
Yeah.
middle
So we have to nominate where the outside of the wall is. So this is what I'm referring to, location line. So that needs to be set to finish face exterior. So I guess the thing is that whenever you are drawing walls, whether they be exterior walls or interior walls, I would always just leave that as finish face exterior. Now, and of course we're going to set the wall height here to ceiling level. We're going to go to the type selector and we're going to find brick veneer 250 timber, this one here. Okay, brick veneer 250 timber. And as I said, we're going to generate a brand new wall type through edit type, this button here. And as we've done with Windows previously, we're going to duplicate. And the name of the new type is going to be brick veneer 240 timber, and just remove the 2 from the end of it.
Okay, I know what's there.
Okay. All right, so new name. Okay, new type.
Okay.
Now, to make our change to the, I guess, the assembly of the wall, we need to go into its, have a look at its structure, which is this here under construction, and we've got this big edit button here. So the edit button allows us to go a little bit further into the wall's assembly properties. And here, in the edit assembly dialog, we can have a look. We've actually got 5 layers that make up this particular wall type. So you can see that at the top here we've got exterior side, at the bottom we've got interior side. We've got our timber frame here at 90mm. A bit further up, or on the outside, we've got our masonry brick at 110. and in layer 2 we've got the air cavity.
What are the core boundary layers?
How
What
did
do
I
they
get that
mean
little
to
screen up again? That one.
Or,
Yeah, so what we're simply going to do is actually click here in this box here and change the thickness of layer 2 from 50 to 40. That's the only change we're going to make. So you can OK that, and you can OK to exit the type properties. And now that we've set the ceiling, the wall height to the ceiling, location line, finish face, exterior, we can then begin to draw in a clockwise direction, working centrally. We can then draw the outside walls. So, like as I said, the first wall along the northern side is it's just over 13 metres. So, I mean, if you don't try and get this accurate, just approximate is fine. So draw the first one and then move down. So that the next one is about 10 metres, but that's fine. Then across by about 4 metres, then up and back. When you get your little alignment path, you can then click and then return back to the start. Okay, so again, nice and central. And you've now generated your external walls. Now, what I'm going to do next is I'm going to get you to add dimensions to this initial set out. But I'm going to show you a very quick and nice technique to do it. And I guess what I'm doing next is I'm sort of now giving you, I guess, or showing you how I would do it. You know, what I call sort of real life, the way we would develop a floor plan in the best, most productive way. And I'm hoping that you'll adopt this as well. But essentially, we now have to get the wall set out correct in terms of our overall measurements before we do anything else. There's absolutely no point in drawing your internal walls at this stage until you are confident that you have your wall lengths correct. All right. So what we do is you either go up to the quick access toolbar and choose align dimension here, or on the annotate tab, dimension panel, aligned. It's exactly the same tool. The shortcut is DI. Now, on the options bar, what we're doing is basically adding permanent real dimensions. Okay, so these are the dimensions that conceivably you'll actually use in your final floor plan. So up on the options bar, you've got a placement method here. So where it says wall centerline, you'll always choose wall faces. Now, the next option here is the pick option, So normally with dimensions, we just pick, place dimensions by picking objects, whether they be walls, windows or whatever. Now I'm going to get you to click here, which gives you a second option which is called entire walls. Now when you click entire walls, what happens is that when you click a wall now, it automatically detects the end of the walls and produces the dimension. So just move that, move up and place that dimension. So to place the dimension, just pick out here or in here, just left click, and that places the dimension. Now, do the same on the eastern wall here. So click the wall and place the dimension out here. Okay. Now, if you pick this wall here, it produces or creates a dimension. If you then go back and pick this wall here, it adds another dimension to that first one. Okay. And then when you move across here and pick in a free space, it will place the dimension. Okay. Whilst you're still in the dimension tool, pick this wall here and pick this wall here, and then place your dimensions out here for the western side. Having produced those primary set of dimensions, you can exit the dimension tool, so hit escape a couple of times or click modify, and they are your initial working dimensions for your set out. So the way that we tackle this from here is to set the length of this wall here. What do we have to do?
Click on the actual measurement there and then type it in.
No, we don't. No, we don't click directly on that. Okay, to set the length of this wall, what has to change? What has to move? Either that wall or that wall has to move. So if I click on that wall and I drag it, see how this is changing? Okay, so in dragging that wall, it makes this wall longer or shorter. So essentially, to change this dimension, we select this wall and click directly on the dimension. Okay, and key in what it needs to be. So this is 13 to 30, enter. So in doing this, we work in a clockwise direction. Okay, so logically, the next wall that we want to set the length of is this one here. Okay, so to set the length of that wall there, we select this wall here. Okay, which activates this dimension. So this one needs to be 10,550. Okay, so then click away, deselect it. Okay, so these two are now correct. So we then say, okay, well we need to set the length of this wall. So to do that, we actually click the wall next to it, this one here. So this one becomes 4070 and deselect. Now that we've changed the length of this wall to 4070, this wall is now correct at 9160. Okay, so that just leaves these two, and basically the position of this wall is going to set these two correctly. So select the wall, and it doesn't matter which dimension you update. Doing one of them will fix the other. So that's now 3360, and that one is 7190. So that's our initial set out. Okay. Okay. Now, what I would suggest at this point is that now that you've got your external walls correct, do a chain selection on them. Okay, chain select the external walls and go up to the modify panel and pin them. Okay, pin them.
Chain selection is just tab, isn't it?
I'll have actual pin.
Yeah, so
Once we've chain selected all of that,
yeah,
click
so
on it.
tab key, just hit the tab key and let it go, and then click, and then when you've got the wall selected, just use the click the pin tool, shortcut PN, and pin them in place. Okay, because the thing is that there's you know, if you don't pin them in place, there's a danger that you'll actually select one of them and inadvertently move it.
Yes.
Now, of course, the next step is to draw or add in the internal walls. Okay. Now, and again, don't try and get the walls placed in their exact position as you are drawing them. Okay. The key to this, okay, the key to this is to actually draw them in, just very quickly, just rough this out, just replicate this design. Just put the walls in, they don't have to be accurate, but just replicate the design internally very quickly, and then worry about the room sizes after you've done that. So can I just have everyone watching me, please, in doing this? And I guess the thing is that this is always going to be daunting if you don't practice it. All right, so, and this is the process. This is the way we work with Revit. It's far different. It's completely different, a different process to what we use with AutoCAD, for instance. Okay, and the thing is that just put the walls in and worry about the room sizes afterwards. So I'm just going to show you the approach I take. I'm not expecting you to follow me, but very quickly, select wall. We're changing to a different wall type here, which is the brick veneer, stud timber 90. Okay, stud timber 90. Finish face exterior is the option here. Ceiling height is the same. So I'm going to start by putting in this wall here. Okay, I'm going to put it up to here because that's a given position. We know it goes there. Now, I know that that connection is not correct, but I'm going to use the align tool to sort it out. Okay, so that's the first wall. Now select CS for create similar. I'm going to very quickly draw in this wall across here and down to here. Escape once. This wall through here. Escape once. I'm still in the wall tool. When a wall going down through here. Escape. A wall here that stops and then goes across to here. Escape. A wall here. Escape. A wall across here. Escape. And a wall across here. So I've just roughed it out, all right? And that's what you need to do. Just do it quickly. Okay, so the thing is that all of these walls need to be single walls in one length, no broken walls, no part walls. Okay, so just do it nice and cleanly. Okay, so if you can just do that, and that will probably do us for today. And when we meet on Thursday for our 8th session, I'll then show you how to put a series of dimensions to pick up on these walls here in order for us to set the exact room sizes. And it all comes back to the align dimension that we used here, the same dimensioning technique. Okay, so just for the remainder of the session, another 5 minutes, I'll just get you to quickly put in those walls.
The stud 90 or the stud timber 90.
Yeah, stud timber 90. If you have a look here, it does give you the wall type. So wall type stud timber 90 here. Wall type is brick veneer 240 on the outside. All right, okay, we'll finish at this point. Thanks, everyone. Like I said, in our next session, we'll sort of run some additional dimensions to pick up on these internal walls, and we'll just go through and just sort out the internal room sizes. All right, so just save your exercise, save it to your USB, upload it to OneDrive, and we'll see you on Thursday. Thanks, everyone.